morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about input or output subsystem organization and interfacing. So actually input and output are the peripherals externally connected to the CPU. These are the peripherals of the computer. So input or output subsystem is organizing and interfacing. Interfacing means these are the peripherals internally connected or externally connected to the CPU. That means if you need, we can connect. If we have to remove, it is possible to remove. So those are called interfacing. Externally, these are the peripherals externally connected to the CPU or computer. So input or output devices are very important in the computer system. They provide users the means of interacting with the system. So there is a separate input-output subsystem devoted to handling the input-output devices. The different components of the input-output systems are IBO hardware and input-output software. So there are many input-output devices handled by the operating system, such as mouse, keyboard, disk drive, etc. There are different device drivers that can be connected to the operating system to handle a specific device. The device controller is an interface between the device and the device driver. So when I'm taking the input device and output device, this I'm taking as a input output device. So input output devices are very important in the computer system. They provide users the means of interacting with the subsystem. So there is a separate input output subsystem devoted to the handling of the input output devices. The different components of the input output subsystems are input output hardware. So there are many input output devices handled by the operating system, such as mouse, keyboard, disk drive, etc. So mouse, keyboard, disk drives are the input devices. So there are the different device drivers that can be connected to the operating system to handle a specific device. The device controller is an interface between the device and the device drivers. Okay, when I'm taking the input output subsystem, okay, we need input output hardware and software. So this software means drivers. This hardware I need devices. So devices are related to the hardware and drivers are related to the software. That is the input output. So there are device drivers are there that will be connected to the operating system to handle a specific device. The device controller is an interface between the device and the device driver. So the different components of the input output systems are input output hardware. Input hardware means we need some devices. So mouse, keyboard, disk drives also devices which are connected to the CPU, and drivers are the related to the software. So it is one example of input output devices. Here I am taking CPU. The CPU is connected to the keyboard controller and a keyboard. Okay, it is one interfacing. USB device another interfacing, and the disk drive is another interfacing. So these are the these are all called peripherals or interfacings to the CPU. So keyboard is one interfacing, USB drive another interfacing, disk drive is also another interfacing. So keyboard, what I need means keyboard controller I need, USB driver means USB controller I need, disk controller I need. So it is belongs to software, and the disk drive is belongs to hardware. This hardware and the software I need to control this one. It is called input output subsystem. So I need a software and I need a hardware to control the input output devices or drivers. Okay, so it is connected to the address line, data line, and control line. CPU is connected. Okay, this keyboard is connected to the CPU, and USB controller to the memory, and the disk drive is connected to the monitor or the video controller. Okay, so different device drivers are connected to the different parts of CPU. Okay, one is connected to CPU, another is connected to the memory, and another is connected to the monitor or video controller. Okay, so there are different. Not only this one, it is an example. There are so many drivers, input output devices are connected to the CPU. Okay, keyboard, USB drive, disk drives are there. So keyboard controller, USB controller, and the disk controllers are there. Okay, it is about the input output subsystem organization and interfacing. Okay, so when I'm taking the keyboard, mouse, etc. Okay, when I'm taking the output device, printer, speakers, etc. Okay, so input devices are some different type of input devices will be there, and output devices are different types of output devices will be there. Okay, so keyboard, mouse, etc. are the input devices. Output devices means printer, speakers are the output devices are there. So it is one example of input output devices. So keyboard, USB, and disk drives are there, and it is about the input. Some examples: keyboard, mouse, etc. The input, and output are the printer, speakers are there. So we are calling as these are the IO devices. So what is the overview of this one? The CPU treats memory as homogeneous. The input output devices are very different. That is, the keyboard and HDD performs totally different functions, and they are both part of the IO system. The interfacing between the CPU and the IO device are very similar. Each input output device needs to be connected to address bus, data bus, and control bus. So the CPU treats the memory, it should be homogeneous. Anything we have to take, CPU is the must. So input output devices are very different. That is, keyboard and HDD performs totally different functions, and they are both part of the input output subsystem. The interfaces between the CPU and input output device are very similar. So the interfacing between CPU and input output are very similar. So interfacing is so what are the input output devices to be connected? Address bus, data bus, and control bus. So these are the must and should interfacing to the any of the CPU or memory. So for the interfacings, we need address bus, we need data bus, and we need control bus. Without these buses, we can't interfacings to the CPU. So what is address bus means? To pass address to peripheral. Data bus means to pass data to and from peripheral. Control bus means to control signals to the peripheral. Suppose I connected a keyboard. Suppose I am connected to the keyboard. So when I'm connecting to the keyboard, how can it will be activated? When I connect into the USB, when I connected to the disk drive, so how it is possible to connect? So address bus means it is finding the which address or which device, port 1 or port 2 or port 3, etc. Which port is connected to the keyboard, which port is connected to the mouse. So address bus is to finding out the which device is connected, and peripheral which peripheral is connected to that one, and it is passing the address. Okay, it will identifying the particular address of the peripheral, and after finding the address, we are passing the data through the keyboard or through the mouse or through the printer or through the speaker. Anything, we have to pass the data to and from the peripheral, and the control signal is nothing but to control the peripherals. And address bus, data bus, control bus are there. It is in between the CPU and memory. So between the CPU and memory, we need buses. Okay, address bus, data bus, and a control bus. There are the three types of buses are there. These are the major role between the CPU and the memory. And input output devices are so many are there. So input output means I'm taking printer, scanner, mouse, etc. Okay, these are the devices are connected to this one. Okay, So peripherals are input or output devices. These input output devices are nothing but I'm taking as a keyboard, USB control, disk drivers. Okay. So these peripherals I'm connecting input output devices means some keyboard, printer, scanner, mouse, or keyboard, anything. Okay. So peripheral devices are nothing but input output devices that are connected to the computer are called peripheral devices. These devices are designed to read information into or from the memory unit upon the command from the CPU and are considered to be the part of computer system. These devices are called peripherals. Example, keyboard, display unit, printer, and common peripheral are the common peripheral. So peripheral devices means input or output, whatever baby, both are there. So input or output devices are connected to computer are called peripheral devices. These devices are designed to read information into or out from the memory unit upon command of the CPU and considered to be the part of computer system. These devices are also called peripherals. Example, keyboard, display unit, printer, and mouse or speakers. These are the peripheral devices are there. And there are three types of peripherals: input peripheral, output peripheral, input output peripheral. So input peripherals means it allows user input from the outside world to the computer. Okay, outside world to the computer. Outside to computer. Okay, these are called input peripherals. These are called input peripherals. So it allows users input from the outside world to the computer, and the keyboard, mouse, trackball, joystick, microphones, and webcams, etc. are the examples of input peripheral. Output peripheral means it allows information output from the computer to the outside world. Printer, monitor, plotter, projector, speaker, and headphones are the output peripherals. Okay, it is from computer to outside world. Computer to outside. Input output means allows both input and outputs. Okay, from outside world to the computer or from computer to the outside world. Outside to the computer or computer to the outside. Okay. So input peripherals are the allows users input from the outside world to the computer. That is a keyboard, mouse, trackball, joystick, microphones, and webcams. Output peripherals allows the information output from the computer to the outside world. Printer, monitor, plotter, projector, speaker, and headphones are the output. And input output peripherals also there. These are the important and allows the both input and output. For example, touch screen is a good example for input output peripheral. So input output module functions. Device communication. An input output module can perform multiple device communication functions such as status reporting, command and information transfer, control and timing to properly manage the flow of information between a computer system and an external device. An input output module utilizes a computer internal resources to perform time management. Okay, input output modules, there are so many functions are there for input output modules. First one is a device communication, another is a control and timing. So what is a device communication? An input output module can perform multiple device communication functions such as status reporting, command and information transfer. Control and timing means to properly manage the flow of information between a computer system and an external device. And input output module utilizes a computer internal resources to perform the time management. Okay, so these are the control and timing. Another one is a device communication. So another one is a processor communication. So processor communication means completing processor communication requires an input output module to carry out tasks including decoding and accepting commands, reporting status updates, and recognizing its own address. Okay, and the error detection means an input output module can detect an array of different problems between its system and an outside device. That includes mechanical errors such as a paper jam in a printer, as well as database issues during the transmission and data buffering. One of the most important capability of input output module is that can manage the transfer speed between the memory, processor, and other peripheral devices that are connected. So processor communication means completing processor communicating requires an input output module to carry out task including decoding and accepting commands, reporting status updates, and recognizing own addresses. So processor means processing the input-output modules and programming and recognizing the addresses. Error detection means we are finding out the errors in the CPU or in the peripherals. Okay, and it is detect the array of different problems between its system and outside world. That includes mechanical errors such as paper jam. As is there any technical issues are there in the printer or in the keyboard or in the mouse? Suppose some keyboard is not properly connected to the CPU. How can it work? It can't work. But it will accepting that the printer is not properly connected. Okay, the paper is jammed and the speaker is not properly connected. If I'm connecting USB, it will give some message. Means it is connected. The port 1 or device 1 is connected successfully. Okay, and some error in the device. So it will be showing some error messages. Okay, that is a error detection. It is about the hardware connections interfacing to the CPU. But error detection is it is showing some error messages to the CPU. And the data buffering. One of the most important capabilities is the buffering of the data, and it can manage transfer speed between the memory, processor, and other peripheral devices that are connected. So input-output steps. CPU checks input-output module device status. Input-output module return status. If ready, CPU requests data transfer. Input-output module gets data from device. Input-output module transfers data to CPU, releasing the control of the bus track of the CPU. So what are the steps of input-output means? CPU checks input-output module to the status. Okay, if it equal to 0, not connected. Status bus S equal to 0 means not connected. S equal to 1 means connected. And input-output module returns status. Okay, return back to the original status, and it is ready. CPU request data transfer. Input-output module gets data from device. Input-output module transfers the data to the CPU, and it is releasing the control of the bus back to the CPU. And input-output module diagram. Okay, it is the external look of input-output module diagram. So how many are there means data register, status control register, external device interfacing, so on, and input-output logics are there. So what are the lines are means data lines, address line, and control line. These are the very important role for the CPU to memory, and it is about the data, status, and control. Data, status, and control. So data lines is about the data, address line is about the status, and the control line is for the controlling. Okay, 3 lines are using for the 3. So it is interfacing to system bus. It is interfacing to the external devices. Okay, so input-output means it is connected to the CPU and memory. CPU to the memory. When I am connecting to the input-output, address line, data, and control. Okay, so data lines, address lines, and control lines are there. So data register, status or control register, these are connected to the input-output logic, and it is external device interfacing logics to there, and external device interfacing logic to that. So when data lines are there, it is about the data, and when about the address line, it is about status. Control lines means it is about the controls are there. Okay, it is about the input-output model of the diagram. So what are the addressing input-output devices means? Input-output data transfer is very like memory access, CPU viewpoint. Each device given unique identifier. CPU commands contain identifier or address, and the input-output module should contain address decoding of the logic. So when I'm going for the address input-output means it is about the address lines of the input-output CPU. So input-output data transfer is very likely memory access CPU viewpoint. Each device given unique identifier. CPU commands contain identifier, and the input-output module should contain address decoding of the logic means it is about the device identifier. And input device means input device is connecting to the tri-state buffering to the data bus. 2 buffering enabled read, input output, and address lines are there. What are the means? A0, A1, A2, A3, A4, A5, A6, A7. So 8 address lines. Okay. So address bus and the control bus are there. So here I am taking about the address and the control bus enable logic. How many address lines are means? 8 address lines here I am taking. 8 address lines I'm taking. Input device to the tri-state buffer to data bus. Okay, it is to the data lines. So input device address into the data line, read operation and write operation there. When the read operation will be there, read and write. So read is different and write is different. So read is to buffering enabled, that is a read operation. Read operation means address lines are input to the read line and it is buffering to the output line, and input output device are the tri-state buffer to the data bus. Okay, we have two there, read and write mode. Write and read. Okay, when the values of the address control buses are correct, the input of device is addressed, the buffers are enabled and the data passes on the data bus. The CPU reads this data. When the conditions are not right, the logic block enable logic will not enable the buffers. No data on the data bus. For example, shown in the input output bus mapped with 11111000 and a computer with 8-bit address bus read IBO map. So when I'm taking input output of memory bar means it is I'm taking the write operation. Memory is there means read operation. So when the values of address control buses are corrected, the input output device is addressed, the buffers are enabled and the data passes on the data bus. The CPU reads the data. So when it is read operation, when it is write operation, it will be depending on your address lines. And the conditions are not right, the logic block will not enable the buffering. No data on the data bus. The example shown in the input output device mapped as the address. The one example I'm taking, it is 8 bits, or that means 8 data lines will be there. When it is a read operation, that is IO by M bar. Output device is nothing but an output device, register from data, enable logic, address line and control bus. So how many address lines are there means A0 to A7, 8 address lines are there. So 8 address lines are there. To register, write operation here, read operation there. Read operation means I am taking as an input. So write I am taking as a it is about the input output. So output device to the register from data bus to register load, write operation A0 to A7, and address bus data lines are there. It is a enable logic will be there. And some variations of this design include buffers instead of the registers. The limitations there is that the output device has to be read the data while the buffers are enabled, otherwise it will be lose the data. Since the output device read data from the data bus, they don't need to buffer. Data will be made available to all the devices. Only the correctly decoded one address bus will read the data. Example shows the output device mapped with all one's address lines in a 8-bit address bus computer with write is a I by O. And read means, so read means like this, write means. So the variations of this design including buffer instead of the register. The limitation there is that the output device has to read the data while the buffers are enabled, otherwise it will lose the data. The output devices read the data from the data bus, they don't need to buffer. Data will be made available to the devices, and only the correctly decoded addresses will read the data. And the output map is the 8 address lines are there, and write IO by M bar, and read means IO by M bar. It is a bidirectional means input and output. So I'm taking here read and write. So read and write means it is a bidirectional. So input output device, tri-state buffering, registers are there, to data bus and from data bus. Okay, read and write will be there, IO and A0 to A7 address lines are there. We can see here input device, tri-state buffer enabled, read A0 to A7. So here output device from data bus, write operation, here previously read operation, and A0 to A7. So read and write operations are parallelly going on. That means it is a bidirectional device. Okay, the bidirectional devices require actually 2 interfaces, one for input and other for output. Same gates could be used to generate the enable signal for both the tri-state buffer and the registers. The difference between read and write are made through the control signals read write, and the examples are shown in combined interfacing, all 1111 to 000. So these are the 8 bits are there. That means 8 address lines are there. Read and write. So bidirectional devices are require actually two interfacing, one for input and other for output. The same gates could be used for generate the enable signal. The difference between read and write are the made through the control signals read and write. Okay, depends on your read operation and write operation. We can find out is their input driver input device is enabled or output device is enabled. And the real system, we need to access more than just one output and one input data register. Usually peripherals are issued with the commands of the processor and they take some actions into the response presenter. How the processor knows into the peripheral devices ready for after the commanding. Programmed input output, interrupt driven input output. So there are types of the real system. We need to access more than of the input output. Usually peripherals are issued with the commands of the processor and they take some action in the response presenter. How to processor knows if the peripheral devices are ready after a command. So programmed IBO, interrupt driven input output. Okay, programmed input output also called hold and IBO and interrupt driven IBO. These are the two types of input output subsystems are there. So modes of data transfer or data techniques, programmed input output, interrupt initiated input output, direct to memory access. So the data transfer between the central unit and the input output devices can be handled in generally 3 types of modes: programmed, interrupt initiated, direct to memory access. So programmed input output instructions are the result of input output instructions written in the computer program. Each data item transfers is initiated by the instruction in the program. Usually the program controls data transfer and from CPU and the peripheral. Transferring data under the programming IO requires constant monitoring of the peripheral of the CPU. Okay, programming means through the programming only we have to give the instructions. So through the instructions written by the program, computer program, it is the programming. Okay. It controls the data transfer and the CPU peripheral, transferring data under programming and constant monitoring of the peripheral. And interrupt initiated means in the program IBO method, the CPU states the program loop until the IBO unit indicates that it is ready for data transfer. This is a time consuming process because it keeps the processor busy, and the problem can be overcome by using interrupt initiated in when the interfacing intervenes the peripheral is ready for the data transfer and generates the interrupt. After receiving the interrupt signal, the CPU stops the task which it is processing in the service of the input output transfer and then returns back to its previous process. When I am going for the multitasking, then only interrupt multi-programmings are there, then only I have to use interrupt initiated. So then the problem can be overcome using the interrupt initiated. So when the multiple task in the programming input output, CPU states programming loop indicates that the data transfer a time consuming process to the busy of this one. So it is receiving the signals, interrupt signal from the CPU to the CPU. So direct to memory access is a very, very important. It is removing the CPU from the path and letting the peripheral device manage the memory buses directly would improve the speed of the transfer. These techniques are known as a direct to memory access. In this interfacing transfer data and from the memory through the memory bus, and the DMA controller manages to transfer data between the peripherals and the memory unit. So direct to memory access, removing the CPU from the path peripheral device, manage the memory buses directly would improve the speed of the transfer. This technique is called a DMA, and the interface of the transfer and from the memory through the memory bus, a DMA control managed to transfer data between the peripherals and the memory unit. Many hardware systems use DMA such as disk drive controller, graphic cards, network cards and sound cards, etc. It is also used for intra-chip data transfer in multi-core processor. In DMA, CPU would initiate the transfer, do other operations while the transfer is in progress, and receive interrupt from the DMA controller when the transfer has been completed. Okay, when the DMA means direct to memory access, means CPU without the help of any CPU, input outputs are directly connected to the CPU. Okay, the hardware system, disk drive controller, graphic card, network cards, etc. It is used for intra-chip data, and a DMA CPU would initiate the transfer of operating while the transfer in progress, receive the interrupt DMA, and the controller when the transfer has been completed. So these are the references. So we are discussing today input output devices and how many types of are there, types of input output devices. So here I am taking CPU to the memory, memory to the monitor. Here I am taking three interfacings or three peripherals connected to the CPU. And what is the overview means address bus, data bus, and control bus are the major role for the CPU to the memory with the interfacings of input output subsystem. And it is a block diagram of multiple input output devices connected subsystem connected to the CPU and memory with the address bus, data bus, and control bus. And the peripheral devices are the keyboard, display unit, printer, etc. There are three types of peripherals: input peripheral, output peripheral, input output peripheral. Input module function is a device function, control timing, processor communication, error detection, data buffering, and input output steps are there. And it is the input output module diagram connected with the data, address, and control lines. And it is about the address input output devices. And it is the input device with the read operation. It is output device with the write operation. Here bidirectional means input read and write both are connected. That is a bidirectional device. Okay. And modes of input output data transfers are three techniques are there: programmed input output, interrupt initiated input output, direct to memory access. Programmed means we are giving some instructions to the CPU, and interrupt means multiple tasks, means at a time multi-programming is there. Then we have to go for the interrupt, means one by one we have to go. Which one is a priority option will be there. And direct to memory access means externally connected memory is connected to the CPU. Okay, input output to the CPU. Okay, without use of CPU. Input output to the memory without the help of CPU. So it is about the input output subsystem organization and interfacing. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.